There's a question from Reddit, and the question says that a solid cylinder of mass m and radius r rests on a horizontal surface. The massless, non-stretching thin string is wrapped around the cylinder and pulled horizontally with the force F on the top of the cylinder in direction x. Static friction acts in x direction between the cylinder and the surface so that it rolls without slipping. So one thing they have given us, without slipping. As seen in the force diagram below, you may assume that moment of inertia of the cylinder about an axis passing through its center is this. So first of all, understand that this is a cylinder, and this cylinder is like rolling like this. So it will be rolling like this. So we have a acceleration here, that is A, and there must be some angular acceleration that can be called as alpha. So we now need, by applying Newton's second law for translational and rotational motion, show that the acceleration of cylinder is this. So we have to prove what's the acceleration, and acceleration is 4f by 3m. So there is like two methods for this, and we will go for both of the methods in this question. See, first method, we all know that f equals to ma. So all the translational motion we will take into consideration, where F is like the force, and this F is also in right direction, so we will add that, and that will be equals to F plus Fs equals to ma. So first of all, you understand that this point will be moving towards left, so frictional force will be on the right side, and force we have already applied in the right side. So frictional force and the F both are in the right direction, so we have added them up and it is equal to ma. So the second equation is of torque. So torque is equals to I alpha. So if we use this point, because I is already given to us, so there wouldn't be any difference. We don't need a new moment of inertia. The moment of inertia about the center is given to us. So the torque, one torque will be like F into R, which will be the clockwise, and the force, frictional force, this will be providing an anti-clockwise direction torque. So it will be negative. It is FSR. So that will be equal to I alpha. I is given to us as mr square by 2, and alpha we know that A is equals to R alpha. So alpha is equals to A by R. So with this R goes off and this R goes off. So F minus Fs is equals to Ma by 2. So we have one equation this and the second equation this. So if we will add these both equations, this Fs will cut down. So it will be like, we can say that adding it, we will get 2F equals to Ma plus Ma upon 2. So this will become 3Ma upon 2. So this 2 will be multiplied here. It will be 4F, and this 3M will come to the denominator. So we got this 4F by 3M. So one solution for this is this. Other solution is like, if we don't want to take this point and we want this point. From center C, we are moving to point A. So you can write like this, like for point A here, and this solution was for the point C. So now for point A also, the F equals to Ma. This will be same because the forces are still same. So this is the first equation, no issues in that. But for the torque equation, now the torque we would be taking the relative point this. So for this point, the force is this. So this now total distance is how much? 2r. So now this distance is 2r and force is this. So F into 2r. Whereas the other forces would be 0 because the distance is 0, because the gravitational is 0, this force frictional is 0. So this both of the forces get nullified. So we are left with only F. So equals to I omega. But this I need to be the moment of inertia from A. So for that, we need a parallel axis theorem that says that I is equals to like ICM plus MR square. So whatsoever the point, we have to move on with the parallel to each other, like this is given to us, but we want this. So it would be like half mr square by 2 plus mr square, because the radius, we are moving one radius down. So this is 3 by 2 mr square. So this will be equals to I alpha. So I'll write it again, equals to, I'll rub this. So this becomes, I becomes this, and alpha is A by R. So this R with this both R's cut off this R. So this will become 4F, and now this 3M become 3M in the denominator. So this is the same answer. So with these, both of the methods are good enough to get good marks and right answer. But for IB, this parallel axis theorem is not there in your syllabus, because you are like, if you are in SL, you don't need this. So you can preferably go with this. And for AP and for HL, if the parallel axis theorem is in your syllabus, then definitely you can use this also. So both methods are good enough to go, and both methods will give you good marks, and you can follow any of the methods. So thank you for being here, and if you still needs one-on-one classes, just let me know, just comment here, and we can start working on your physics. Thank you for being here.